Hi everyone, welcome to the Joy of Coding at Portland State University. In this course, we use the Java programming language and development platform to explore topics like object-oriented programming, unit testing, and code refactoring. I realize that even though the syntax of Java might be familiar to people who have programmed in C or Python before, it's unlikely that everyone in the course has experience working with the language and its toolset. These slides are meant to give you a high-level overview of the Java programming language, object-oriented programming, and some of the command line tools that are used to develop in Java. This ought to get you started with your journey to learn about contemporary software development techniques. So the Java programming platform itself consists of, first of all, the Java programming language, but there's also a set of libraries. These are Java classes that you can use in your own code. We'll be seeing a lot of that in this course, as well as the Java virtual machine that Java programs run in. We'll be looking at the syntax of the language in these sets of slides, and it should be pretty familiar to someone who has used C before, or maybe Python. But unlike C, Java is object-oriented and has features such as a built-in Boolean type, support for international character sets, and automatic memory management. So over this set of slides, and we'll probably do two parts, we'll talk about the Java programming language itself, we'll talk about object-oriented programming, and again, the tools that we use to compile and run Java programs. So what is Java? If you look at the original Java white paper written a number of years ago, Java touts itself as a simple, object-oriented, distributed, interpreted, robust, secure, architectural neutral, portable, high-performance, multi-threaded, and dynamic language. That's a lot, and a lot of buzzwords and code words that might not make too much sense here at the outset. I like to think about Java as the way James Gosling, one of the original authors of the language, says it. C++ without the guns, knives, or clubs. If you've worked with C++ or a low-level language like C, you know that while there's a lot of power in these languages, there's also a lot of things that you can get wrong and really shoot yourself in the foot. Java attempts to address a lot of those concerns by providing a safe and secure environment for developing code. Additionally, Java gives you a platform for developing code that is portable and independent of the hardware that it runs on. A large part of the power behind the Java platform is the APIs, the application programming interfaces, that give you a standard set of libraries for dealing with everything from common data structures, things like linked lists and hash tables, to doing file I/O, to everything from doing graphics. The nice thing about Java is that you don't need to write this code on your own. You can use code that has been written by someone else and has been battle tested over many, many years. Unlike older languages that were developed for mainframe computers, Java came of age during the time of the internet, and so it has support for facilities for doing networking, for doing graphics, and for security built into the language and built into the platform. These aren't things that are bolted on afterwards. So Java's been around for a while, and I think it's fair to say that it has proven itself as a language and as a platform for developing both application and enterprise level computing. If you want to learn more about Java and download the tools for working with Java, visit the OpenJDK website at openjdk.org. Now let's talk about the Java language itself. It was developed a number of years ago by Ken Arnold and James Gosling at Sun Microsystems. And the fundamental programming unit in Java is a class. And we'll see what classes are in a little bit. Classes have methods that consist of statements that perform work. This is the code that you write. This is what you're telling the computer to do. Every class in Java is what's called a package. Packages provide a namespace, a naming context for classes and for their fields and methods. And when you run a Java program, it starts with a main method, just like a C program does. And a main method has one argument, which is an array of strings that are the arguments that are put on the command line. So if you want to write hello world in Java, it looks something like the following. You're declaring a class, and the first thing that you do in a class declaration is to specify what package it's in. So you'd say package, and then the name of the package, which is edu.pdx.cs410j.lang, and then you declare the class itself. So you say public class hello, and we'll talk about what public means in a little bit. The name of the class is hello, and that class declares it has one method. The name of the method is main, and it's public, static, and void. It returns nothing, and the name is main. It takes one argument, an array of strings. And because this is hello world, all you're doing is printing hello world. And the way you print a standard output in Java is that you say system.out.println, and then you give it a string, what you want to print, hello world. Hopefully this looks a little bit familiar to you from either C or C++ or Python, but there are probably some things that are new to you, things like static and what exactly system.out means. We'll be exploring all that stuff here in these slides. If you're coming from C or C++, the execution environment for Java might be a little different. Java was designed to be platform independent, meaning that the developer writes their code once, and the idea is that they don't need to recompile it to work on different platforms. This makes Java programs really easy to distribute and then also be able to run on a lot of different sets of hardware. The way it achieves this write once, run anywhere promise is that Java programs, these are the classes that you write, are compiled into a binary format called class files. And these are class files that are ultimately run on the Java virtual machine. The class files contain instructions for that Java virtual machine called bytecode. These are very low-level instructions for the Java virtual machine. They're different from hardware instructions. There's some similarities. But the whole idea is that the execution has been abstracted into this Java virtual machine. And really the JVM provides a lot of power to the Java programming platform. Of course, the JVMs themselves are most often implemented in a low-level language like C, so things can be highly optimized, especially the conversion of bytecodes into machine instructions that are ultimately executed on the native hardware. So let's talk about how you go about compiling a Java program. So the source code for a Java program, which looks a little bit like that Hello World program, is written in a text file. That's what contains the source code, the declaration of the class, and the implementation of all the methods. Now there's some naming conventions in Java that help keep the code organized. One of those naming conventions is that the name of the file corresponds to the name of the class. So the hello class resides in a file named hello.java. Furthermore, the directory for that source file corresponds to the package that the class is in. So as you may recall, our hello class was declared in a package called edu.pdx.cs410j.lang. Well, the directory structure for the hello.java also corresponds to the package. So you'll have an edu directory underneath that, a pdx directory, a cs410j directory underneath that, finally a lang directory, and that's where your hello.java file resides. Admittedly, if all you're writing is hello world, this does seem a little overkill, having all these directories just for one file. But as you'll experience, and as many other programmers have experienced, as your code base grows, it helps to have these conventions to keep things organized, to make it easy to understand where files are, and so you can find things quickly. The Java Development Kit comes with a tool called JavaC, which stands for Java Compiler, and this is the thing that will convert the source code into bytecode that can be interpreted by the Java Virtual Machine. Again, that's one of those class files. So if you execute the JavaC program inside the directory that your source code resides in, and give it the -d option for destination, a command line like javac -d ~classes, and so you want to put the class files, the generated bytecode, into a directory called ~classes. Then you give it the name of the source file, hello.java. When you execute that command, it will compile the hello.java source code. If there are any errors, it'll tell you about them. And if there's not, if it's able to successfully compile the source code, it'll create a class file where you told it to. So in this case, the name of the class file also corresponds to the name of the class. So underneath the ~classes directory, you'll have an edu pdx cs410j lang directory, and in it, the hello.class, which is the binary bytecode that can be executed on any Java virtual machine. The Java Development Kit also includes an executable called Java, and this is the thing that invokes the Java virtual machine and runs the main method from some class. When you provide the name of the class whose main method you want to run, you provide the fully qualified name of the class. So for instance, our hello world is edu.pdx.cs410j.lang.hello. You also need to tell the Java virtual machine where to look for those class files that you created when you compiled your code. The way you do this is that you specify the -class path or -cp option to the Java program. Alternatively, you can also set an environment variable in all caps class path to where you want to be able to load classes from. So to run the Hello World program, you would execute a command like the following. You would say Java to invoke the Java virtual machine, -cp for the class path, and then you'd specify the class path. This is the same directory that you compiled the source code to, ~classes, and then the fully qualified name of the class, edu.pdx.cs410j.lang.hello. And when you run that command, it prints out hello world. It executes the program. To help you understand exactly the series of events that happens to get you to this point, we have this diagram here. You start with a piece of Java source code, a .java file. You run the compiler, javac, on that to create a class file, a .class file. And then you execute the Java program using the Java executable that runs it on the JVM. Let's talk more about the Java programming language and start with its type system. So you can have types that are classes, and we'll see some examples of that, especially in the object-oriented programming section. But Java also has 8 primitive types. These are types that look a lot like the primitive types in C and are highly optimized for this kind of data. So for instance, there is a type called Boolean, all lowercase Boolean, which has 2 values, true or false. This lets you determine whether or not some value equals to another value, for instance. There's a char type, and this provides a character type which is implemented as 16-bit Unicode 1.1. Maybe in other languages you've worked with, you've learned about ASCII or maybe extended ASCII, 1 characters. But in C, that can vary from compiler to compiler, to runtime, operating system to operating system. Java wanted things to be consistent. And so whenever you see a char in any Java program, you know that's going to be a 16-bit Unicode 1.1 character. There are also 4 kinds of signed integers. There's byte, which is 8-bit, short, which is 16-bit, int, which is 32-bit, and long, which is 64-bit. Similarly, there are 2 kinds of floating point numbers that both adhere to the IEEE 754 1985 standard. You have a 32-bit float and a 64-bit double. And so all these numeric types allow you to do arithmetic operations, plus, minus, subtraction, divide, all that kind of stuff on these various types of numeric data. Now, when it comes to specifying literal values of these numbers in the Java programming language, they're a lot like C. So you can have int literals that just look like a number 42, or an octal, or hexadecimal. And there's also this notation in Java that allows you to basically have a separator character between digits in a number. You can use the underbar, which it kind of looks like a comma. So 1996 can be represented as 1 underbar 996. Makes things a lot easier to read. Long literals are the same as int literals with just an L, either uppercase or lowercase, appended to it. And then character literals work just like C. They are delimited by single quotes. So you have quote, Q, quote, or an empty character, quote, quote. There are also string literals in the Java programming language, and you see those delimited by double quotes. So we saw, like in Hello World, we had, quote, hello, quote. It's important to note that when you see quote, hello, quote, this represents a string object. It is not an array of characters like it is in C and C++. Java programming language has comments. They look a lot like in C and C++ style comments. Here's an example. We have a class called product, and above the declaration of that class is a comment that says this program prints out the product of 2 doubles. Inside the main method, we see a couple other of comments that demonstrate that there's both C-style comments, so / star and */ and also C++ style comments that begin with / and take the rest of the line. Now note in Java, there are these things called documentation comments, and those are comments that reside between a / and a */. We'll see more about this later, but these documentation comments are important, and they describe the class or method or whatever program element directly follows them. There's a tool called JavaDoc that will extract the information inside of these comments to generate HTML or really any kind of documentation for the classes. And one of the things that this brings is then the ability to have a very well documented set of APIs for your classes by having the documentation right there next to your code. Now, when it comes to control flow in your programs, Java has all of the control flow statements that you expect from any programming language. It has, if else, and it has loops like for and while and do while that have continue and break. Very familiar to anybody who's worked with C. And one of the questions everybody asks is like, is there a goto? And the answer is no. Java actually has reserved the goto keyword in the language, and there is no definition of it. So you can't have a variable called goto. You can't do anything with a goto. Goto is bad. Java also has what's called the enhanced for loop syntax, which removes the need to have an iterator variable when you loop over some amount of data. So here's an example of iterating over an array using the enhanced for loop to compute the sum of the ints inside an array. So instead of saying, for int I equals 0 while I is less than array.length I++, you can abbreviate that by just saying, hey, for int I in the array. So you see there's, int I colon the array, and then you can just compute the sum that way. When writing software, we need to anticipate things that might go wrong. So for instance, you might divide by 0, or you try to read a file that doesn't exist, or accidentally index beyond the end of an array. You want to be able to handle these unexpected situations nicely in the code without having to unnecessarily clutter up your code with a bunch of error checks. Did an error happen? Oh, isn't an error about to happen? The Java programming language uses a mechanism called exceptions to signal an error without needlessly cluttering up the code. So what happens is that when the Java virtual machine detects that an error condition has occurred, again, something like a divide by 0 or indexing beyond the end of an array, there is an object created called an exception, and that exception is said to be thrown, which means that the code stops executing, and instead, the code is alerted to the presence of this exception. Now, it's very important to the user of your code, which might be you if you're writing code against it, that they know that an exception might take place. This is a good way of just documenting what might happen when you invoke a method, for instance. And so as a result, methods declare that they might throw an exception. So, we'll see an example shortly, but it'll be like, hey, I'm about to read a file, and by the way, I might throw a file not found exception if that file is indeed not found. So when the error occurs, an exception is thrown, and the code that called that method that encountered the error has the opportunity to catch that exception, meaning that they'll get the exception object and handle it appropriately, maybe printing out an error message, or taking a different branch of logic. Because an exception is an object, Java provides lots of different kinds of exceptions, and there are two important categories of exceptions that you should know about. The first are called checked exceptions. And these are conditions that are unexpected, but not terribly surprising. So for instance, a file can't be found. Right? That's not, that happens. The user provides the name of a file that doesn't exist. A file has been deleted out from the program. When you read from a file, when you try to write to a file, you should anticipate that it's possible that something might go wrong. Because these really aren't that surprising, if a method might throw a checked exception, it must declare it in the throws clause. So here's an example of a method called readFromFile. It takes a file object and returns some piece of application data. I need something small like app data to fit on the slide. But the declaration of the method also says that it might throw a file not found exception. This is a clear signal to the code that calls this readFromFile method that if something goes wrong, or rather one of the things that might go wrong is that the file wasn't found. So that is an example of a checked exception. There's also a category of exceptions called unchecked exceptions. And these are more rare and usually signal that there's something kind of wrong with your program, like a divide by 0, or maybe, hey, you've run out of memory. We'll see some more examples of unchecked exceptions later, but you can recognize unchecked exceptions because they descend from either Java Lang runtime exception or Java Lang error. Now, I mentioned before that an exception can be caught and handled and have the program do something in response to an exception being thrown. And the way you do that syntactically is that when you call a method that might throw an exception, you surround it with what's called a try-catch-finally block. So here we call a couple of methods that might throw some exceptions. So inside that try block, we're going to say, hey, try executing this code, and there might be some exceptions that are thrown. So we're going to call that readFromFile method, which might throw a file not found exception. And then we're also going to call another method that says write to database. So this takes first the connection to the database, the DB connection, and then also that data that we read from the file. This is just example code. It doesn't have to compile. It's meant to just show you what the syntax for working with exceptions is like. So we have that try block there. And then following the try block are a series of catch blocks that handle different kinds of exceptions. So a catch block declares that it handles a specific type of exception. Looking at that second catch block, we see that that will catch an end of file exception. And in this case, it might be okay that an end of file exception was thrown when the file was read, and so we just ignore it, right? We don't execute any code. But in that first catch block, we catch two types of exceptions, a file not found exception or an SQL exception. A file not found exception might be thrown by read from file, and then that SQL exception might be thrown by the write to database method. If either of those exceptions are thrown, it'll be caught in the catch block there and assigned to a variable called EX. So when you say, file not found exception pipe SQL exception EX, the exception object that was thrown will be assigned to that EX variable inside the catch block, and then you can work with it. In this case, what we're going to do is we're going to print out an error message, or call a method that prints out an error message, and the message that we're going to give it is the result of invoking the getMessage method on the exception object, on that EX variable. We'll learn more about exactly what all of this means later, but I think you can probably figure out that we can work with the exception objects and do things with them. Now, try and catch. Whenever you have a try block, you are required to catch an exception. There's also an optional finally clause, which is code that will execute regardless of whether or not an exception was thrown in the try block. And this is a good place for cleanup code. So that's exactly what we do here. In the final block, we close the file stream that was being read, and we also close the database connection that was used to persist the data. Again, this is just good examples of the kinds of things that you might do to clean up after some IO has been performed by your program. We saw in our Hello World program that there are these things called packages, and every class is in a package. I want to spend a little bit more time talking about what packages are and the benefits they provide. In the Java development ecosystem, there is a tremendous amount of code reuse. And in order to distinguish classes that might have the same name, so for instance, you might have two companies that both have a user class in their libraries, we can use packages. The Java programming language leverages packages to provide namespaces for classes. And this allows you to group classes together logically, and also enables you to have multiple classes with the same name in your application. Maybe that are coming from different libraries provided by different projects, but allows them to have the same name classes, and as long as they're in different packages, they won't conflict with each other. In Java, every class is in a package, although the package declaration is optional, and so then if you leave off the package declaration, the class will be what's called in the default package, which is a fine thing to do like in computer programming 101, but as soon as your application grows to any size, you'll want to use packages to keep things organized. Now, packages have a hierarchy to them. As you saw, there's edu.pdx.cs410j, and that's what I use for all the classes that are in this course. As you learn more about the Java APIs, you'll see that the standard Java APIs all begin with Java or JavaX for extended things. Now, the code that you write in this class will be in a package called edu.pdx.cs410j.yourUserID. Because you're all going to implement the same assignments, but until you all have classes with the same names. However, the way we distinguish each other's classes from each other is that we put them in different packages. And just as a reminder, the way that you specify a package is that you put it as the first line in a source file. You say package, and then you declare the name of the package that the class will reside in. Now, when you want to use a class from a package that's different from your own, you need to tell the Java compiler where that class resides by specifying its package. So when you reference one class from another class, you must either fully qualify it by putting the full name of the class there, or you need to import it into your code. An import is similar to a pound include from C or C++, but the mechanism is very different. So here we have an example of a class called packages. It itself resides in the edu.pdx.cs410j lang package. And you'll notice it has an import statement. It says import java.io.file. This tells the compiler that, listen, if you see capital F file somewhere in this class, what I'm referring to is the file class from the Java IO package. And so you see there in the main method, we create a file object from the first command line argument. And then we're going to get a URL object that corresponds to that file by calling little f file for the name of the file variable to URL. And that returns an instance of an object of class URL. Now URL resides in the java.net package. I could have imported java.net.url into the program, but in this case to demonstrate what a fully qualified class name looks like, I've written java.net.url. Now note that if you have a class that's in the java.lang package and the string class, capital S string, is in java.lang, those classes are implicitly imported into your programs. So you don't need to explicitly import java.lang.string. You can just use string and the Java compiler will figure it out. Same thing goes for the system class. So whenever you see something that begins with a capital letter in Java, it's very likely the name of a class. Additionally, you can instruct the compiler that you are importing essentially any class in a package by using the syntax import, the name of the package, java.io, and then .star. This will import all of the classes in a package. And so when the Java compiler goes to resolve capital F file, it'll look in java.io. Please note that the star is not recursive, so you can't say import java.star to import all Java classes. It only matches the name of the package, not any name in the package hierarchy. Before we continue to explore the language, I just want to highlight some differences between Java and C++. As I've already mentioned, Java doesn't have a goto statement. We can't branch like that. Unlike exceptions in C++, Java has some exceptions that must be caught and handled by calling code, those checked exceptions. And then it also has unchecked exceptions that don't need to be caught. Unlike C and C++, Java doesn't have pointer arithmetic. There's no pass-by reference. You can't have a reference to an object and then add 7 to it. That's not the kind of thing you can do in Java. And Java doesn't have operator overloading. So you don't use things like left shift for I/O. You can't change the meaning of plus or divide. It's just not something that the language has. And I think that's okay. I like to know what my operators do. There's no file preprocessor in Java like there is in C and C++, so no pound define, no pound include. Most of that stuff's used for hardware-specific or operating-specific things anyway, and so it doesn't really make sense in Java. And also note that the negation operator, bang, can only be used with Boolean types, and so you can't do things like negate the value of an int. This gets confusing, and so in Java you have to say hey, if bad not equals 0 instead of if bad. Now let's look at some of the other tools that come with the Java Development Kit. There's a tool called jar, which creates a Java archive that basically takes multiple files and puts them all into one archive file. It's similar to tar on Unix or zip, right? So the whole idea is that you're taking a bunch of files and making one file out of them. What jar lets you do is put related code and application resources, so class files, or maybe you have images or text files that you read as part of your program, puts them all into one file and makes it then much easier to distribute all of that code. You can also do things like digitally sign jar files to verify that they came from a certain source, a certain developer. The command line options for jar look a lot like the tar tool from Unix. So here's an example of creating a jar file that contains the classes that you compiled. So you might recall we compiled the hello world, the hello class, into the ~classes directory. And so you can use jar cf for create a file, create a jar file, to create a classes.jar file with everything in the current directory, so dot. Then you can view the contents of a jar file with jar tf. T, I think, stands for table of contents. And when you run that, it prints out everything in all the entries in the jar file, including entries for what's called the manifest, which is some metadata about the jar file, And then there's the contents, and so you'll see there is a directory, an entry hierarchy that ends up with edu/pds/cs410j/lang/hello.class, and that's the one class file that we had created already. And again, the advantage of a jar file is that you can then take this one jar file. It would have more than one class in it. It would probably have dozens of classes in it, and then distribute it to your customers, to your clients, so the people that want to use your code. So not only do jar files make distribution of code easier, JVM also has the ability to read classes from a jar file. So if you invoke the JVM with the java-cp, the class path, and you put a jar file on the class path, it will read the classes that it needs from that jar file. So here's how you can run the Hello World program by having the jar file on the class path instead of the directory containing the classes. You'll be seeing jar files a lot in this course because I've developed a lot of code and I want to keep it easily distributable and usable by putting it in jar files. So there is a cs410j.jar which contains all the classes that you need for your projects. And then I have things like the examples.jar with all my code examples. When you submit your projects, you use a grader.jar. Again, the whole idea here is that jar files are what's used to distribute and share Java code. And to reiterate a couple of points about jar files, they don't have to contain just class files. They can have pictures, sounds, or again, text resources. Anything that's needed by your application can reside inside a jar file. And that jar files also have special entries that are called manifests that have information about the jar file, like who created it, what version of the library it is, information about digital signatures, all sorts of good stuff. And there's even a Java API that can be used to manipulate jar files, to open them up, to maybe add entries, things like that. It's in the java util.jar package. Another tool that comes with the Java Development Kit is called JavaDoc. And what JavaDoc does is it generates HTML documentation for your Java classes, looking at the source code and extracting information that is in those documentation comments that begin with /** and end with //. In addition to the text that resides in documentation comments, there are some special tags that you can add inside your JavaDoc comments to specify things like the author. So you can say @author, which is who wrote it. You can also describe the parameters to a method and the return value of a method with @param and @return. You can use @throws to describe the exception and really the conditions under which the exception might be thrown by a method. And there's also limited navigation within JavaDocs, and so you can say, well, this class will refer to this other class, and you can use @c to do that. Here's an example of a class that has a bunch of JavaDoc comments in it. Above the class declaration, you can have a JavaDoc comment that describes the class, which is exactly what that does, and it specifies the author of the class and then what version of the class it is. The declaration of the invert method has a JavaDoc comment that describes what the invert method does. It returns the inverse of a double. You can use code tags to generate a fix with font for a keyword, something like double. But more interestingly, the JavaDoc comment contains tags that describe the parameter, that D, that is sent to the method, and this is the double that you want to invert, as well as a description of what the method returns and the fact that it might throw in a legal argument exception if double is 0. And what the JavaDoc tool will do is extract all of this information from the code, from the documentation comments, and format it into nice HTML, including hyperlinks off to things like the description of what a legal argument exception is. Now, when you run JavaDoc, you need to tell the tool a couple of things. You need to specify where the source code lives, and you do that with -sourcePath. Also, where the compiled code lives, with -classPath. And then also the destination directory, which just like Java-C is the -D option to the tool. So if you are working with the example code that we have so far, you can generate HTML API documentation for it by invoking the JavaDoc tool with the -classPath argument, with the -sourcePath argument, -D, so you want to create the HTML documentation in ~docs, and then the name of the class that you want to generate documentation for, edu.pdx.cs410j.lang.javadoc. The nice thing about Javadoc is that it allows Java developers to create documentation which is standard. It looks like all other Java documentation out there, but is also quite powerful in terms of the ability to understand a set of classes, what they do, and how to work with them. So I think this is a good place to stop for right now. We've learned a lot about the Java programming language. We've still got some more stuff to talk about with regards to object-oriented programming, but we'll do that in a different screencast. Here's some things that I hope you've learned in this lecture. I hope that you've learned that Java programs are built with classes, and classes contain methods that do work. And an important method is the main method, and that's where execution of your program starts. Java programs are compiled from source code into this intermediate binary bytecode format, which is then run on the Java virtual machine. And this allows Java programs to be run on any hardware platform or operating system platform on which the Java virtual machine is available. The Java programming language itself was highly inspired by the C programming language, and you'll recognize many of the primitive data types and control flow structures from C. And because error handling is a really important part of software development, Java uses exceptions to provide sort of a built-in way of expressing and then handling errors that occur during your program. Java uses packages to organize source code and to avoid conflicts between two classes that might have the same name. And finally, the jar tool in the Java development kit creates one file that contains many other files, like class files and images and such. And so it allows Java programs to be distributed more easily. And there's also the Javadoc tool, which creates HTML documentation from Java source code that's in a standard format. And here again, it helps Java code be more easily consumed by who's ever using it. And that's all for right now. Thank you for learning about these fundamental concepts in the Java programming language. I hope it gets you off to a good start in the joy of coding here at Portland State University.